Starting with Chapter 4, we're going to be spending a lot of time working with angle measurements, in particular with how they are measured out on a circle. So to begin, we're going to look at a couple different systems for measuring out angles. The most common way of referring to an angle measurement is by using degrees, where there are 360 degrees going all the way around in a circle. The problem is sometimes you have not a whole degree, you need to mark out a smaller angle measurement, so a decimal, and that's a fairly straightforward way to indicate that measurement. But another common method is using this degrees, minutes, and seconds system. That's what the DMS stands for, degrees, minutes, and seconds. So the degrees will refer to the whole measurements of the 360 degrees all the way around a circle that you guys are familiar with. But there's also a minute, which would be 1/60th of a degree, kind of like with a clock. That's why it breaks down into 60ths. And if you were to break down even a minute into 60 separate intervals, we would call those seconds. And you can see that the different symbols for those will be indicated by the open circle in the top right corner, kind of like in the exponent spot. Or you could have a single apostrophe or two apostrophes to indicate seconds going by. So for converting from the degree, minutes, and seconds to the degree system, you're just going to take the number of minutes you have and divide that by 60. And then if they give you any number of seconds, so if you see the two apostrophes, then take whatever that number is and divide it by 3600. You should get two different decimals for doing these two different divisions. You will add those numbers together to the whole number of degrees, and that will be your answer. So that'll change it back into a decimal form. The other way around, if you're going from a decimal of degrees into the degree, minutes, and seconds, then you'll be multiplying by 60 over 1. So just take the stuff that comes after the decimal place. Don't mess with the whole number part. That part doesn't change no matter what. But whatever comes after the decimal place, you'll multiply by 60 over 1, and that'll change it into minutes. And then if you still have a decimal after doing that, then repeat the process, multiply by 60 over 1 again, and that number will be how many minutes that you have. So only do the part of the number that comes after the decimal place, multiply by 60. This should be a very similar process for any of you who have taken chemistry and done that stoichiometry or unit conversion process, because 60 minutes is equal to 1 degree. So we're multiplying by 1, which is not changing its value. We're just converting it from one unit to the other, converting it from degrees into minutes. So here's our first example, and you can see that we have degrees, minutes, and seconds as indicated by the different symbols noted on the last slide of notes. And the process that I referred to was to take the number of minutes and divide it by 60, and the number of seconds and divide it by 3600. So we're just going to be computing 24 over 60 and 36 over 3600. Now, if you put these into your calculator, for 24 divided by 60, you're going to get the number 0.4. And for the number 36 over 3600, you're going to get the number 0.01. So then if you look back at the instructions I had for you on the last slide, it says after you've done the dividing minutes by 60 and the number of seconds by 3600, just add those values together. So taking our original number, which was 42, we're going to have 42 plus 0.4 plus the 0.01, which gives you the number 42.41. So 42.41 degrees is the same thing as 42 degrees, 24 minutes, and 36 seconds. It's just a different way of identifying the measurement of that angle. Now we're going to do the same thing backwards. This time we have a decimal measurement of degrees, and it wants to change it into the degrees, minutes, and second intervals separately. Well, the first part of the number is going to stay exactly as is, the 37. So that part is going to be 37 degrees. But then whatever comes after the decimal, the 0.425, what I told you here was to take that decimal only and multiply it by 60 over 1. So in this case, I will have 0.425, and that's degrees, times 60 minutes over 1 degree. And then what happens is the degree symbols cancel out. So all that's going to be left here is the 0.425 times 60. So plugging this into the calculator, I will have 25.5 minutes. But again, if you look back at the rules I gave you, I said if there is still a decimal, and there is because I have 25.5, then I need to multiply that decimal again by the conversion fact that there are 60 seconds in 1 minute. So now I'm going to do another multiplication, and it's going to be the 0.5 part, the 0.5 minutes, times 60 seconds in 1 minute. It's the exact same values you see from a clock. So again, the minutes units will cancel, and we're just doing 0.5 times 60, which is the same as 1/2 of 60. So that gives me 30 seconds. So what's left here is I have 37 whole degrees, and then we had 25 whole minutes, because then we took whatever was left, the 0.5 part, and we converted that, and 30 seconds. So this would be another way of referring to an angle, 37.425 degrees. Now, I won't lie, personally, I find this system perfectly accessible enough. It makes enough sense. People can understand what's being referred to there, but there will be some textbooks and some problems that will break it down into this minutes and seconds system. That's why it's important to be able to look at that number and convert it to decimals, or vice versa if you're asked to. Now this slide here has the information that will be most important out of this lesson. The degrees, minutes, and seconds, that's honestly not super important for this class. We will not use it very frequently. It will only come up rarely in the class. But the radian measurements, being able to change from degrees to radians or vice versa, will be something we do constantly. So if you're familiar with the degree measurement to measure an angle between two lines, like between these two lines indicated here, a radian is just another system for measuring that angle gap. Now, radians will become more useful, especially when we get into the trig side of things, because it will simplify some of our computations. So to define what a radian is, it's taking a circle, and then whatever the radius of the circle is, if you swing out an arc that has the exact same length, so if, like, let's say your radius is 2, then swing out an arc of the circle around the outside that is 2 long as well, then the angle measurement between those two pieces will be 1 radian. So it's the angle measurement of a circle where the arc length is equal to the radius. That's what a radian is. Now, going all the way around the circle, that's why the circumference is 2 pi r. It kind of comes from this definition of what a radian is. So here's our conversion that we're going to be using. For going from a degree measurement to a radian measurement, you're just going to multiply by 1 pi radian over 180 degrees. These two things are equal. 1 pi radian is equal to 180 degrees. That's why 2 pi all the way around is the circumference. So if you multiply by this fact, since this equals 1, it doesn't change the value, it just changes your unit. The same idea that I was mentioning with chemistry and stoichiometry. So you're just converting a unit. Degrees to radians multiplied by pi over 180. If you're going the other way around, very similarly, you will be multiplying by 180 over pi. Because if the number for your angle already has radians in it, then you want radians to cancel. So the radians goes in the bottom of your fraction that you're multiplying by, and then you'll be left with the degree measurement on top. So I'll do a couple examples of this as well. So this is an angle measurement in degree form. So if I want the degrees to cancel, I'm just going to put the degree fact on the bottom. So 180 degrees will go on the bottom, and 1 pi radian will go on top. So it's always 1 pi radian and 180 degrees. Just memorize those two values and then put the one on the bottom that you need to make the units cancel out. So now the degree symbols will cancel. Also 90 over 180 would be 1/2. So you'll end up with 1 pi over 2 or 1/2 pi either way. So this would be pi over 2 radians. And then here's 270 degrees. Again, this has a degree symbol. So I'm going to be multiplying by 1 pi radian over 180 degrees. So again, just reduce the fraction. The degree symbols will cancel because you have one in the numerator, one in the denominator. If you want to write this over 1 to help see that, you can. So the degree symbols will cancel. And then your fraction 27 over 18, this is also a fraction that reduces. This would be the same as 3/2. So you can do this as 3 pi over 2 or you could do 3/2 pi, it's the same thing, but this is the most common way to write that angle, 3 pi over 2 radians. So you'll start to memorize these values too after we've been doing them for a while. You'll, just like you're very familiar with 90-degree angles, I hope at this point, for right triangles, for example, you'll just start to recognize that that's the same thing as a pi over 2 radian measurement. Okay, so now we're going backwards. One common feature of radian measurements is they often have a pi in them. It won't always be the case, but they will often have a pi symbol in them. Whether it does or does not have the pi, the process does not change. All that you do is multiply by 180 over pi radians. So it's nice when it has a pi in the original angle, because that means the pi's will cancel, and then I just have to simplify 180 over 3. So in this case, that's going to be equal to 60 degrees. And again, this is a measurement that you'll end up memorizing after you've done it a few times. Same thing, I have negative 5 pi over 3, so I'm going to multiply by 180 degrees divided by pi. So the pi's will cancel, and then I'm going to have 5 times 180 divided by 3, or what would kind of make this simpler to work with is simplify the 180 over 3, because that's going to be equal to 60, and then 60 times 5 would give you 300. So negative 300 degrees is the same as negative 5 pi over 3. One more formula to share with you guys, and again, this won't be as important as the conversion from radians to degrees and vice versa, but sometimes you'll be given either an arc length, the radius of the circle, and the central angle in the circle. Usually you're given 2 of these 3 pieces, and you're asked to find the third. So whatever information they've given you, plug those numbers into the formula up here, which says that the arc length will equal the radius times the central angle. The central angle is, if you imagine a circle being drawn, it's that angle that's in the middle of your circle. So that's what the theta refers to here. If you haven't seen this symbol before, that's called theta. So that will be the central angle. It's the angle that goes into the center of the circle. And then the arc length is that distance that's connecting the outsides of the angle. And the radius, of course, is the distance from the center to the edge. So here's an example. They've asked us to find the length of the arc, S, which has an angle measurement of pi over 4, and it's in a circle with a radius of 2.5 meters. So since the formula is S equals R theta, we have S equals the radius is 2.5, which I'm actually going to write as the fraction 5 over 2 instead. And then the theta value is pi over 4. Since the other number was already a fraction, I found it easier to rewrite 2.5 as 5 over 2. So now when I do my multiplication, I'll have 5 pi over 8. Now, depending on what the directions say in the question, you will often want to rewrite this number as a decimal. So 5 times pi divided by 8, for example, should come out to 1.9635. It's also important to note that the angle that they give you for the central angle, that does need to be in radian mode. So if they gave you the information in degrees, you would have to use the concept I showed earlier, where you're converting that angle into a radian measurement, and then plug in the radian measurement to compute your arc length in this case. Conceptually, what we've just found is that if we had a circle, and if the angle is pi over 4, this is actually a pretty small angle. It would look about like this. So it's a fairly small angle inside of the circle. And if the radius of that was 2.5, then what we just found is that this length from here to here is a length of about 1.9 meters using the same unit that they gave us. But that's just for the concept. You don't have to actually show that for the question. So that's it for the notes. Again, the emphasis, please be very comfortable with the process of switching from degrees to radians and radians to degrees. The other information is important, but not nearly as important as that part.